Hello everybody and welcome back to Higher Learning Test Prep's online video tutorial series. Today we're going to look at this natural science passage from the ACT reading section from December 2014. And we want to look at a few things. How do we get through this passage effectively and efficiently? We want to make sure that we're skimming correctly so that we're getting the main idea but we're not spending too much time. So that on top of getting the main idea, we're getting an idea of the structure or layout of the piece, where is specific information located. We're going to look at this skim, and then we're actually going to talk about just how to quickly use our skimming to efficiently go through the questions. So we're not going to answer every question, but we're going to show you where the information is based on skimming and how to go through the questions effectively. It's not always just in order. Okay. So the passage is adapted from an article, Flotsam Science by Sid Perkins. Here we go. In January 1992, a freighter crossing the Pacific ran into rough weather. As the ship heaved through the storm-tossed seas, several cargo containers came loose, fell overboard, and broke apart. 7 months after the spill, the plastic ducks, beavers, turtles, and frogs that came washing up onto the beaches. Scientists who track ocean currents were ecstatic. I typically read this one in full. This is a nice little beginning of our passage, just talking just about, it's giving us a little anecdote, a little story. Even today, members of the Toy Tub Armada occasionally make landfall. Date and place of each of the nearly 1,000 toys recovered from to date provide a data point. Now let's go down here. A set of deep water and surface currents spanning an area the size of the continental United States that generally flows counterclockwise around the northern Pacific. And I see this proper noun, which must be what we were talking about. This gyre is the set of deep water currents. Okay, so now I know that the toys have something to do with measuring the currents. Next paragraph. In most of the world, the dispersal of flotsam isn't of major interest to researchers. But, whenever I see this word but, I'm going to keep reading. But along the bustling trade routes, yada, 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 fills in the details of how a Pacific subarctic gyre works. Okay, so now we know for sure the toys are being used as data for the gyre. The ocean is teeming with a variety of scientific instruments. End of the paragraph. I guess this is all one long sentence. So probes specifically designed to ride the surface currents have sensors which can quickly become obstructed by algae, barnacles, and other organisms. Okay. What's more, probe batteries fail within months. That's only a small fraction of the path around the gyre, so we see 1,000 kilometers. I think what they're saying here is we have probes. They're not that effective. Okay. We've never had a good handle on how long it takes to go around the gyre. Okay, we'll keep reading here. Actually, just so we know that this is line 40, so we have to skip over to here. This was a matter of just getting all the information on the chalkboard and the restrictions of the technology. But anyways, we just left off here with saying that we don't have a good handle on how long it takes stuff to go around the gyre. To map the currents and clock their speeds, Ebsmeyer, Royer, and other teammates circumvented. Okay, so now we're getting into how they've used this floating junk. Many of these items can be traced back to specific spills. Okay, so they're using junk instead of probes. The team's oldest data points and the most eco-friendly result from an eruption of Alaska's Mount Katmai, some of the pumice. Okay, so more junk floating around. Now we're over here at line 55. Each entry into the researcher's Flotsam database includes the latitude and longitude. Okay, so now we're just talking about what they're doing with the data, how they're collecting the data, or how they're organizing the data. Because of the sheer volume of flotsam data, the scientists have been able to discern the typical configuration and average speed of the currents in the gyre. Okay, so now these are the results, that it's been effective. Results of computer simulations indicate that floating objects can be swept along several paths. End of this paragraph. This conclusion fits with observed recoveries of items that came at intervals of several years rather than being spread evenly through time. Okay, so this is more results here. According to the simulations, now we have the actual speeds listed. Once the researchers came up with these answers, they analyzed long-term records. A pattern nobody noticed until the ducks came along. So that these this flotsam data was actually really useful and gave us something that we didn't know about before. End of the passage, last paragraph. Studying the dispersal patterns in flotsam is interesting and creative. However, when we see words like however, we want to pick up where we left off. However, he cautions the date of recovery of an item found on a beach may not reflect when it actually washed ashore. Ebsmeyer and his colleagues have good measurements, but I'm not sure of what. Okay, so just by reading little pieces of each paragraph, we got the main idea. We read a little bit more at first. It's not just perfect where we read the same amount in every paragraph, but a little more at first to really get what was going on. And then right about here is where I started moving more quickly. We said, okay, there's probes in the ocean. The probes don't always work that well. Some quote that says essentially the same thing, that they've never worked that well. We have our experiment. A little side note on some data points that aren't from litter. Then we had a little bit more about the database. Then we had what we were able to find out, the results, more of the results, more results here, the ramifications of the results, and then somebody questioning this whole experiment. Okay, so we can break up. Now I know, and this is what you want to do on natural science. You want to know not just the rough layout, but what it's a science passage. So we have an introduction, the situation that we have at hand, an experiment to solve a problem, and the results. Now let's go to look at some of the questions and say, how would we answer these in the most efficient way possible? Now, the first question asks, which of the following questions does the passage not answer? You might be able to cross off a couple of these as you go, but I would save 31 for the end because you'll definitely have a better idea of what's going on at the end. And this is certainly one where you're going to cross answers off as opposed to look for. You can't really look for what is not in the passage, so you look to cross off stuff you do find in the passage. 32 says, according to the passage, one disadvantage of using scientific probes. Well, we know exactly where to go. That's going to be right over here. There's some probe issues going on right here from like 24 to about 37, 38. Okay. Next one, the 8th paragraph where deleted the passage would primarily lose an example of. This is one that I would save till the end as well, because we want to consider what everything else, what is going on in every other paragraph. You might be able to get somewhere right now, but I would save this for the end. 34, the passage indicates that scientists have been able to determine the typical configurations and average speed despite. Well, where did we talk about the results, the typical configurations? That would be somewhere over here. The typical configurations, we see that language right here. We know it's the ACT. They're going to use the exact same words. Okay, next one. Freeland notes that a problem with the flotsam database is that, so we look for this dude Freeland's name. If we were talking about a problem, I would probably go to the last paragraph where we're being skeptical of the whole situation. So there we go. 36, within the passage, the main purpose of the statement in lines 7 and 8. Well, we know what's going on in the whole passage pretty much by now. Let's go back to 7 and 8. That's scientists who track ocean currents work static. So what is the point to... I mean, we can answer that now. We know that it's just kind of a funny thing to say because when we've trashed or thrown a bunch of trash in the ocean, scientists don't, it doesn't seem like scientists should be happy, but they are. Because, of course, it's useful for them. So it's not that it was inappropriate. Now, G looks pretty good to me. This transition from the discussion of spilled toys, scientific significance. Maybe that looks okay at first. Introduce a conflict between researchers and the shipping industry. No. What is the main purpose? I think we're going to talk about the scientific significance. I think H is the best answer. I don't think that statement necessarily reveals this information in G. Sorry, I knew I said we weren't going to go through the answers, but that was one that I felt like I needed to go through. Okay, 37. According to the passage, what most happened to most of the toys spilled in the 1992 incident? Well, I would maybe save this one for the end, but I will say this, that We do have nearly 1,000 toys recovered. We have some evidence for this. We know where to go when we're talking about the toys. It's pretty much just right here. I don't think there's really anywhere else where we're talking specifically about the toys. Okay, next one. According to the passage, at what point do probes used to measure surface currents usually lose power? Well, probes, we talked about that over here. The probe stuff was mentioned in these 2 or 3 paragraphs here. Okay, as it is used in line 42, the phrase harnessing the power of most nearly means, of course, we know exactly where to go here to answer this question. And then 40 asks us, the author compares the speed of the Pacific subarctic gyre currents to the speed of typical human swimmers most likely to. Well, those speeds, I remember seeing them in that short little paragraph here. Why does he do this? This is something that you're going to have to consider. What is the point of comparing the speed to a swimmer? It's probably so that we understand what that speed actually means. Okay, so you can see that we can go through with a good skim. We should be set up to go and find the information fairly quickly in each case. So the key to moving quickly through these questions here, and of course there was a couple that we skipped and would come back to at the end. Aside from skipping questions that require a lot of information that are best answered at the end, the other thing is getting a really good skim. And if you do that, you'll be in great shape. Okay, folks, I hope that skim and explanation helped you understand how to approach science passages in the reading section. Take care and let us know if you have any other questions.